U.S. Steel has two plants in northwest Indiana, the Gary Works facility and the Portage plant.
The Gary Works facility is on the border of the Grand Calumet River, and the Portage plant is on the border of the Burns Waterway. U.S. Steel manufactures and produces many steel and tin products. Hexavalent chromium, a chemical carcinogen, is a byproduct of the manufacturing process.
It is being dumped into the water system that surround these plants. These water systems flow into Lake Michigan, contaminating the water that people use. The Portage site also borders the Ogden, Indiana National Park. Groundwater testing on the U.S. Steel Portage site have shown an increased level of hexavalent chromium, and the problem is not being properly dealt with by legislation. We sat down with the CEO of Arcadis, a company that works to rehabilitate sites that have been damaged by dangerous chemicals.
The CEO, Leanne Thomas Foster, explained to us the threat of hexavalent chromium's structure as a solvent.
Many of the water reports in Chicago, there are solvents in our groundwater. There's solvents in our drinking water now. Solvents are very difficult, and the reason why solvents are difficult is they are much heavier than water, and so they tend to sink, and then they'll find path of least resistance, and they will travel. So there's one case where I saw it was a dry cleaning chemical that had, and one of which was similar to hexavalent chromium, and it actually sunk down, hit a sewer line, traveled 5 miles, and it just travels. So they don't know that, it ended up on record being 5 miles. I don't know if it was officially like from that said source, but this site was incredibly filthy. So the solvents have that ability to sink and travel and migrate.
This problem is especially devastating due to the close proximity of the mills to Ogden National Park and the Indiana American Water Company.
In many cases, they'll use different types of booms that I've seen that have absorbents on them they don't pick up water, but they'll pick up a solvent or an oil or something else. So they tend to, and sometimes you'll see them like the Army Corps pull them out when we have like a boat that'll sink in the lake, and you'll see all the fuel coming up and the solvents, you see a sheen. And so they'll actually put these booms out that are spill booms, and they actually will pull a lot of that solvent in and collect it when it's possible. Yeah. In small sort of hotspot treatment zones, they'll cut a huge section out, put it to the side, dig down, and they'll treat it with an oxidizer like sodium permanganate, for example, and then they will mix the soil with that oxidizer and then treat it. The other way to do it is also to use borings. Depends on the soil type and the clays that are there, but they also take borings and they actually send the material in below grade and treat it like a blast treatment underground. There's also electrical resistance heating where they actually put in these metal like almost plates into the ground, and they'll heat it, and it brings that material up through the soil, and it collects in this sort of blanketed area, and it collects into a collector, and they do extract it from the soil. There's just dig and haul, there's traditional pump and treat. We'll actually be pumping materials up, but then also treating from another maybe upwind source or some up area source where they'll be treating here, and then maybe down a hill where it could be more prevalent. They'll treat it, and then they'll be pulling it up out of the ground, somewhere else that's close.
One of the criticisms of the EPA and the Superfund Act is that it takes a very long time to restore sites. We sat down with the chief civil engineer at Arcadis to learn more about the issue.
The time frame can vary widely, but for a large site, it's going to start at as little as 4 or 5 years and could be 15 to 20 to 30 years. It could take a very long time. In resources, you'll have a team of people working on that for the duration. It's not going to be full-time, but you'll have consultants, you'll have contractors. The person that owns the property will be committing resources to managing it. In addition, the community invests resources because usually the community is involved. So, I couldn't put a number on it, but you just think about all the people that are involved over a 5 to 30 year period, somewhat consistently. It's a large effort by a large group. I think the failures of Superfund is when everything gets tied up, and I'll blame the attorneys. When engineers and contractors are involved, you're seeing an improvement in a site. When people are negotiating in the courts, sites, you don't see any progress at all. So there's certainly success stories, But I think the failures are also when people are arguing about who's going to pay and how much is going to pay and how much they need to clean up.
I would like to see, and we proposed this, a more efficient streamlining of those reports going through the system, and more staff and capabilities to move those projects quicker. I think they're too slow.
30 years ago, there were thousands of love canal type sites, and if that doesn't sound familiar, that's the classic standard from the 70s, where there were some really bad sites, and that's before they had any cleanup programs. Now, maybe there's maybe a handful of sites that are that bad, and there's a large number of very less severity sites like gas stations. There's always going to be lots of smaller areas that are bad, but the bigger ones, the ones that are affecting huge communities, are definitely getting addressed and cleaned up.
Hazardous waste sites in the United States are a very big problem, and they are not going to go away overnight. However, experts like those at Arcadis believe that a future without hazardous waste sites is very possible. Before that can happen, though, we need to free up the human resources in these programs and secure more funding for them.